my hope will never die.
Okay, so today we'll be looking at the 2015 Calc AB FRQs. So let's get started. So we're going to be starting off with number 6 today. And so that's, wait a sec. This is the non-calc section. Why do I have a calculator here? One second. Okay, that's a lot better. So we're going to start here. You guys always have to remember that this is the non-calc section. The last problems, I think 4 through 6 on all the Calc AB exams, and I think BC exams, are non-calc. So make sure store your calculators away or don't use them. So for this one, we're going to look at the problem number 6. Consider the curve given by the equation y to the third minus xy is equal to 2. It can be shown that dy over dx is equal to y over 3y squared minus x. So immediately looking at this problem, we can see that this problem is a lot like a slope field equation formula problem, except you're not given a slope field, so we don't have to worry about that part. It's just your old differential equation stuff, and it'll be easy. So first we'll look at part A. It says, write an equation for the line tangent to the curve at the point -1, 1. So here we can see, we know that we're going to be looking for the slope first. And we see that we're given the equation to find the slope right away. It's dy over dx, or y prime. And that's what we use to find the slope. So we can just plug that in to the point -1, 1. So if we plug in that to our equation up here, we will get that the slope is 1/4. And so that's their slope at -1, 1 is 1/4. And so now we can move on and plug that into our point slope formula. Y minus y1, 1 right here, is equal to 1/4, which is our m. X minus x1, in this case our x is -1, so I automatically moved that so that it's +1 right there. And that's basically all the work you need to show for this type of problem. So this problem is actually really easy, but that could be understood because the other parts are a bit more hard to understand. And so then you start off and you have your answer right here. Y over x plus 5, y is equal to x plus 5 divided by 4. So part B of this FRQ is a tad trickier than part 1, but still very easy. So we can see we're told to find the coordinates of all points of the curve at which the line tangent to the curve at the point is vertical. So this is more of like a conceptual thing that you have to understand. Basically they're testing to see, when do you know that there's a vertical tangent line at a point? And so if you go back to our basics, we know that a vertical tangent line is when our slope is undefined. And when our slope is undefined, it means our denominator of the slope is 0. And so basically all we need to do is then solve for when our dy over dx, or a y prime, or the slope, is equal to 0. So whenever the denominator, this part, is equal to 0. So we can do that right here. As you see, we have 3y squared minus x set equal to 0. And we get 3y squared equals x. Now, we might just think, where are we going to go from there? However, we can go more in depth from there. So now that we have what x is equal to, we can actually replug this back in to our original equation right here. Y to the third minus xy is equal to 2. So doing so, we can plug that in. And once we replug that in, we can see, and then we solve for y. We can see that our y value is going to be -1. So the tangent line is going to be vertical at some x value and -1, comma -1. So now we have to find our x value, and that's very easy. We just go back and do y to the third, plug in our y value, which is -1. We find that the tangent line is vertical at 3, -1. So the main thing for this part of the FRQ is knowing what does a vertical tangent line mean. That means the slope is undefined. A horizontal tangent line means that the slope is 0, but a vertical tangent line means the slope is undefined. So with a vertical tangent line, or the horizontal tangent line, you're going to have the numerator be 0. With the vertical tangent line, you're going to have the denominator be 0, because that makes the whole entire slope undefined, rather than just a 0 over 0, or this one's going to be like a 1 over 0, and that's undefined. Well, this is just 0. And that's basically part B. Okay, so part C of this FRQ is to evaluate dy squared y over dx squared at the point on the curve where x is equal to -1 and y is equal to 1. So here we can write down our basic information of what we're given, and we can have our dy dx point right here. So now first we want to try to find what dy dx is, because that'll help us later in solving our derivatives. So what we can do right here is that we can start by just plugging in our points. So if we plug in our points, we can go 1 over 3, 1 squared minus -1. And from there we can get that equal to 1 over 4. So now we have what dy dx is equal to at the point -1 comma 1. So now that we have our dy dx, we can kind of move on from there. So basically we can move on to find d squared y over dx squared, and actually we can find the derivative of that, which is basically our second derivative, and that will get us 3y squared minus x. Now I'm just going to put the y prime for right now, so we can just sub that in. 6y dy over dx minus 1 divided by 3y squared minus x. And this is just using the basic quotient rule to break down this equation. So we're just breaking this down. You always have to remember to have your y primes ready. So we have a y prime here. No, I forgot to do a y prime there. But that's our dy dx, and y prime are essentially the same thing. And now we can just sub everything in. So I'll leave the subbing in to you guys, but at the end we get our answer as 1 over 32. So I guess the main thing is that you recognize the format, and so that you can, instead of having to solve all this dy dx, you can just plug in the points to dy dx, get the 1/4, use the quotient rule on this dy over dx, and then just plug in the 1/4 at these y primes. Because if you try to solve it, isolate it with a differential equation and all that, your problem in your life will get a lot messed up if you don't use this 1/4. So it's best to just plug in all your numbers before you simplify, so that way you don't have trouble simplifying. Because honestly, this looks like a mess, and when I tried to solve it the first time this way, it was a total mess. So if you start to plug things in early, it'll make your life a lot easier, and you won't have any trouble with this problem at all. In fact, this 6 problem, basically, the slope fields, like Mr. Farrar said, it's a gimme. It's a really basic and easy problem. And good luck.
Oh my god!